Hello everyone, welcome back to our session where today we will discuss important questions and their solution. Today we will cover catalysts and reagent, an essential topic in chemistry. If you are preparing for exam, stay tuned as today we will be covering the questions which are asked in the university paper, and let us see the answers step by step. So the first question which was asked in university paper for catalyst and reagent is, what is Lindahl's catalyst? Explain its uses and in partial reduction of alkyne and its selectivity. So let us understand what is Lindahl's catalyst. The Lindahl's catalyst contains a palladium which is coated on, basically it is coated on the calcium carbonate. So here it should be calcium carbonate, CaCO3. And this reagent is used for partial reduction of alkynes. So this reaction is stereoselective, and as a result we will be getting the products which will be cis isomer. So let us see the example. The example is 2-butane where CH3C triple bond C CH3 plus hydrogen. So the reduction using lead plus calcium carbonate in the presence of lead acetate. So you will find here the three bonds are partially reduced to double bond, and the product we are getting is cis 2-butene. So as we are getting cis 2-butene, that means syn addition of hydrogen molecule is taking place on the triple bond, and we are getting cis isomer of butene. So similarly, one more example we can see where CH3, CH2, CH2 7 times, C triple bond C, and CH2, CH2 7 times, COOH. So here you will find that same using Lindahl catalyst, the triple bond has been reduced to double bond, and the product we are getting is cis product. So this is question number 1, which is asked for 5 marks. Similarly, let us see the next question. Explain the use of SiO2, that is selenium dioxide, in oxidation of active methylene, that is methyl, and allylic hydrogen atom with a suitable example. So basically selenium dioxides are used for oxidation, and they can oxidize only the active methylene or methyl groups without affecting the carbonyl carbon group. So let us see the example. CH3CHO, that is acetaldehyde, when reacts with selenium dioxide, you can find the CH3 which is active, which is just near to the carbonyl carbon, has been oxidized to CHO, that is aldehyde. So CH3 has been reduced oxidized to aldehyde. So we will be getting CHO and selenium plus water. So active methylene group is converted into the carbon or the carbonyl group, which we can see in the next example, where cyclohexanone when reacts with selenium dioxide, you can find that the active methylene group, which is just next to the carbonyl carbon, has been converted into the carbonyl group. So we are getting two carbonyl groups just besides next to each other. That is consecutive carbonyl groups we will be getting in cyclohexanone. The next third one is allylic hydrogen gets hydroxylated using selenium dioxide. So here the example is 2-methyl 2-butene where CH3C CH3 double bond CH3 when reacts with selenium dioxide, it is getting converted as CH3C CH2OH. So the second carbon methyl group is active methylene group, which has been converted into hydroxyl group. Okay. without affecting the double bond. So the double bond is not affected, only CH3 which is getting oxidized to hydroxyl group. So this is how the selenium dioxide can be used for oxidation of active methylene in different ways, in 3 different ways. So next example, let us see. The next question is, give the oxidation of alkene to epoxide by meta CPBA. So here MCPBA is used as oxidizing agent, and alkene is oxidized by MCPBA into an epoxide in a good yield. The reaction is known as epoxidation. So the example you can see here is 1 propene, so CH3 CH CH2, that is 1 propene, when reacts with the reagent, that is CP metachloro para benzoic acid. So it is MCPBA is nothing but metachloro per benzoic acid. So when you reflux it, you will find that metachloro per benzoic acid, you will find that one oxygen is extra in the carboxylic group. So here COOH. So it is per acid. So here this oxygen which is extra is used like in hydrogen peroxide. It is also used for oxidation. Similarly, CPPA is also used as an oxidizing agent, and the double bond is converted into epoxide group. Yeah, epoxide ring. So here the double bond gets breakdown and you will get a epoxide. So let us see the reaction of per acid transfers the oxygen atom to the alkyne by syn addition. The reaction is stereospecific. This means that cis isomer of alkene gives cis product and trans isomer will always give you trans product. So I think this is clear to everyone. Now next question which was asked in university exam is, explain Rosamond reduction with suitable example. So basically Rosamond reduction is a name reaction which is also asked in many CET exams or entrance exams. So here the acyl halide can be reduced by hydrogenation in the presence of palladium coated on barium sulfate as a catalyst. So palladium is a catalyst, is poisoned or deactivated by barium sulfate. So whenever you can see on arrow lead and barium sulfate, you should understand that it is a catalyst which is used for Rosamond reduction. And one more reagent which we require for Rosamond reduction is acyl chloride, that is COCl. Okay, so in this reaction you will find that this reaction is actually a partial reduction where the acyl chloride is converted into aldehyde. So let us see the example. Here you will find benzene ring. At para position there is methoxy group and acyl chloride, which on reduction only this acyl chloride, that is COCl, get reduced to COH, that is aldehyde group. Okay, so let us see one more example. A general reaction which I have shown here, RCOCl, that is acyl chloride. So on arrow if you see, it is PB BaSO4, that is Rosamond catalyst which is used. So you will be getting RCHO plus HCl. Now why it is called as partial reduction? Because the next example if you see, there is a double bond as well as acyl chloride, that is a benzene ring CH double bond CH, C double bond OCl, and barium sulfate with lead. So here you will find that the double bond is not reduced, only acyl chloride has been reduced to aldehyde. Double bond is as intact with the reagent. So here in short, the Rosamond reductions are used for partial reduction, which where the acyl halides are converted into aldehydes using lead barium sulfate. So you should remember that whenever you see the word Rosamond reduction, these you should always remember lead and barium sulfate and acyl chloride. So now the next one, how is ranitidine prepared? How is it used for reduction of the following compounds? The first question which they asked for ranitidine is olefins. Then next is nitriles. And third one we have to show the use of ranitidine for nitro compounds. So let us see what is ranitidine. Ranitidine is also known as spongy nickel. So it is a spongy nickel, and the preparation of when fine divided nickel with aluminum alloy is boiled with NaOH, that is sodium hydroxide. Aluminum dissolves, leaves behind highly porous form of nickel, which is known as ranitidine. So now I think you are clear that ranitidine is nothing but porous form of nickel. So the reaction we can show here, 2Al plus 2Ni, that is nickel, sodium hydroxide. When you boil this, you will be getting NaAlO2 plus NiH2, that is ranitidine with hydrogen. This is nickel with hydrogen. So ranitidine is a alkaline and it is deactivated by acid. Therefore, it can be used for compounds which are not affected by basic conditions. Let us see one by one. First, olefins. So here in the first example, we can see that olefins are converted into alkanes. So let us see the example. Here the alkene with aromatic ring we have taken as the starting material. Ranitidine we have taken, and the conditions are 4 atmospheric pressure, 25 degrees Celsius. You can find that the double bond in the alkene has been converted into single bond. Similarly, let us see the next example where you will find the ester, and the esters are converted into using ranitidine, and the aromatic ring was there. The aromatic ring has been converted into hydrocarbon, that is cyclic hydrocarbon. So the aromatic ring has been reduced. Now the next example is of nitrile, which was asked in the question. Nitriles are nothing but cyanides. So nitriles can be converted into amines using ranitidine. So let us see the example. Benzene ring, it is at having CH2 and CN, that is cyanide, which is also called as nitrile. So when ranitidine is introduced with this cyanide, the reduction takes place and the cyanides are converted into amines. So you can find that C triple bond N has been reduced to single bond C single bond N, where the double bond, two bonds are broken down, and in short we can say that 4 hydrogens are added on the double bond. So 2 hydrogens are added on carbon and 2 hydrogens are added on nitrogen. So there is a formation of CH2, CH2, NH2, that is amines. Now the next is nitro compounds. Nitro compounds are converted into amines. So here the example we have taken is nitrobenzene. Nitrobenzene, when reacts with ranitidine, in the presence of ranitidine at 25 degrees Celsius and 4 atmospheric pressure, you can see that the nitrobenzene has been converted into benzamine. So the NO2 group here, NO2 group has been reduced to NH2 group. So the oxygen, in reduction we know that it is addition of hydrogen and removal of oxygen. So these two oxygens have been removed and there is addition of 2 hydrogens. Okay. So let us see the next question, which was asked in university paper, that is write the structure and uses of Ziegler-Natta catalyst. This is very one of the most favorite question which is asked by the examiner about Ziegler-Natta catalyst. Either it is asked in match the pair, either it is asked in fill in the blanks, and here they have asked the short note. So let us answer this question. Ziegler-Natta catalyst is prepared from titanium tetrachloride and triethyl aluminum. So here you will find titanium tetrachloride, that is TiCl4, and there is ethyl groups attached with aluminum, which is triethyl aluminum. So aluminum is having 3 ethyl groups. Now when you are going to react these two things, whatever product you will be getting, which is called as Ziegler-Natta catalyst. So you can see here that the ethyl group has been attached with titanium, and whatever the reagent we are this catalyst we are getting, that catalyst is known as Ziegler-Natta catalyst. So it is just the combination of titanium tetrachloride and triethyl aluminum. So Ziegler-Natta catalysts are generally used for synthesis of polymers. So in polymerization lesson, the polymers, the previous video we have already seen that for polymerization of HT, that is high density polymers, uh, there is use of Ziegler-Natta catalyst. So here the Ziegler-Natta catalyst is used to prepare polyethylene. The ethene reacts with itself to form a polymer, which is polyethylene, and the catalyst used here is Ziegler-Natta catalyst. So this we already seen in the lesson polymers in the unit 4. Now next question which is asked, this question will be asked for 3 marks. Now the next question, that is question number 6, write the application of NBS as a catalyst. So it is nitrobromosuccinamide, N-bromosuccinamide. NBS is nothing but N-bromosuccinamide. So this is used as a catalyst. Now this basically is used for preparing allylic bromination. Okay, NBS is used for preparation of allylic bromination. So let us see the example. Here cyclohexene, you can see cyclohexene as a starting material which reacts with NBS. This is NBS structure. Okay, a succinamide where the bromine is attached to nitrogen, so it is NBS, nitrobromosuccinamide. So in the presence of CCl4, that is carbon tetrachloride, you will find that the allylic carbons, these are the allylic carbons where the bromine will get attached to this, either this side or this side. Okay, either allylic this carbon or this carbon, the bromine can get attached. So the product we are getting is cyclohexene, and on the carbon, suppose we start counting from here, 1 2 3 4 5 6, so it is 1 bromo 2 hexene, 1 bromo 2 hexene. Okay, so this is the product we will be getting. This is one of the important question which can be asked for complete the following reactions. So the next is where the benzylic hydrocarbons can be similarly brominated. So here there is no allylic bromination, but the benzene which contains a CH3 group, that is benzylic hydrogen, which gets brominated by bromine. So benzene ring CH2 and Br. So here one of the hydrogen is replaced by Br. Now next, the NBS is also used for brominating the carbonyl compounds at alpha position. So if the carbonyl carbon is there, there is no allylic group present, but the carbonyl carbon can be brominated at alpha position. So as we all know that carbonyl carbon, the carbon next to the carbonyl carbon is called as alpha carbon. So this is alpha, this is also alpha carbon. Next will be beta, this next will be beta, and so on. We already seen when we have learned this. So the alpha position will get brominated either this carbon or this carbon, because there is no other substituent on the ring. So either this carbon can be, alpha carbon can be brominated, or this carbon can be brominated using NBS. So the reflux with NBS, we can get alpha bromo cyclohexene hexanon, cyclobromo hexanon. Now the next question, which is very favorite, which is always asked in question number either 4 for 5 marks, that is complete the following reaction. So you can see there are almost 10 reactions which I have solved here. That is a p-methyl benzyl acetyl chloride. So here you can see that it is acetyl chloride, then hydrogen, and on arrow you can see lead, barium sulfate. So once you see the things on the arrow and acyl chloride, it should be immediately you should strike that it is Rosamond reaction or Rosamond reduction. So acyl chloride we have already seen while solving the questions that acyl chlorides gets converted into aldehyde. That is C will be replaced by hydrogen. So it is p-methyl benzaldehyde. Similarly, the nitrile. Here the next question is nitrile, that is cyanide, and ranitidine is there on the arrow. So the reduction of nitrile gets converted into amines. We already seen this also. So these two questions we have already seen in the previous questions. Now next is benzene. Benzene reacts with your PtO2 and H2. So your PtO2 and H2 is nothing but Adams catalyst. Okay. So platinum dioxide and hydrogen. So it is going to have reduction, complete reduction you can see here. That is using Adams catalyst, which is nothing but PtO2, that is platinum dioxide in the presence of acetic acid. So benzene, that is all the pi bonds of benzene rings have been reduced and we get the answer, that is cyclohexane. So aromatic ring has been converted into your unsaturated saturated hydrocarbons, cyclic saturated hydrocarbons. Now the next one is cyclopentene. Cyclopentene. You can see 1, 2, 3, 4, 5. 5-membered ring having a double bond, cyclopentene, where we have to react with platinum dioxide at 4 atmospheric pressure and 25 degrees Celsius. So we have to solve this. Even though I have shown the answers, basically in question paper it will be written question mark will be there and you have to write the answers for this. So here I have already completed the reaction, you have to complete the reaction. So in the question papers they will only give you cyclopentene and on arrow they will be giving you the reagents. Okay, so this is the answer which we have got after reduction of olefinic double bond with platinum dioxide. So the olefinic double bond will get reduced and you will get a cyclopentane. Pentene has been reduced to pentane. Now the next complete the following reaction is, you can see that the olefinic double bond of aromatic ring is reduced using ranitidine, that is allylic one. So here the ranitidine is going to reduce only the allylic double bond and you will be getting CH2CH3. Okay. Now the next one is, you will find a ester, alpha beta ketoester. Beta ketoester is reduced using sodium borohydride. Now sodium borohydride is again a reducing agent. It is said to be a mild reducing agent, so it can only reduce keto groups. So here the keto group has been reduced to hydroxyl group, that is the double bond O has been reduced to single bond and one hydrogen will be taken by carbon and one hydrogen will be taken by oxygen. So here the keto has been converted into alcoholic group. Now the next one is butane aldehyde, where the aldehyde group has been reduced to alcohol, primary alcohol, using red aluminium. Either it will be red aluminium or on arrow they can give you lithium aluminum hydride. So you should know that either red aluminium or lithium aluminum hydride can be used to reduce the aldehyde to primary alcohols. So aldehyde has been reduced to primary alcohol. Again same, the double bond O has been the pi bond has been reduced and hydrogens have been added up at carbon and oxygen place. Okay. Now the next one is, we already seen this reaction, 8th one, that is cyclohexanone, where on the reagent used is selenium dioxide. So we know that selenium dioxide is used as a oxidizing agent and here the carbon next to the carbonyl, that is alpha position carbon, will get oxidized to carbonyl group. So already this reaction we have seen while solving the question answers. Now the next one is the nitriles. The nitriles are reduced to amines, we have seen. Only here the reducing agent is lithium aluminum hydride. So cyanide has been reduced to amines, CH2, NH2. Now the last one I think you can guess. On the arrow it is PD, BaSO4 and acyl chloride. So obviously this is what? This is a Rosamond reduction. Okay. So the acyl chloride has been reduced to aldehyde. So it is very easy. You have to just complete this reaction and write the products. If you remember, you can write the names of the product, then you can get the full marks. So thank you for watching, and if you have any doubts you can comment below, and you can even like and subscribe this channel. You can watch the other questions and answers of polymers. The links have been provided below. Thank you for watching, and let us meet again for the next session of Catalyst and Reagent, where we will be seeing the most important questions which are asked in the university. So bye till then.